Hello guys. Good morning. I'm Sachin Shinde, and I'm here for the Spark Foundation internship. And the task 2 is to prediction using unsupervised machine learning. The data set is given for us is iris, and we have to predict the optimum number of clusters and represent it visually. Okay, so name cluster itself nothing but it is from unsupervised machine learning. So what is unsupervised machine learning? It is the machine learning model we are using that neither classified or not labeled, and allowing algorithm to act accordingly without any guidance. Let's see. So in this unsupervised machine learning model, machine will group the information based on the similarities and patterns and difference without any prior training of data. So we don't have any labeled data. So it is nothing but unsupervised machine learning model. We are going to use k-means machine learning model under the unsupervised machine learning. So what is k-means? K-means clustering is an unsupervised machine learning that we know. There is no labeled data for this clustering. Unlike in supervised learning, K-means clustering algorithm computes the centroid and iterates until we find optimal centroid. It assumes that the number of clusters are already known. It is also called flat clustering algorithm. So, main concern to find out k value here. So optimum k value, then initializing kth centroids and create your clusters, assigning each point to nearest centroid, and make your cluster braiders. Move each centroid to the center of each cluster. Repeat steps 3 and 4 until your centroid converge. So there are 4 to 5 steps to follow for the k-means clustering. Okay, this is iterative process actually. Okay, these are the libraries which are required for our iris dataset. So NumPy, Matplotlib, Seaborn, Pandas, scikit-learn dataset, and cluster for k-means. Okay, NumPy, Pandas, and Matplotlib, they are core libraries for numerical computation, scientific computation, data manipulation, and visualization, whereas sklearn is machine modeling, used for machine modeling, model building. So here we have iris dataset, and in this we are having 1 2 3 4 5 6 total 6 number of features in that id: sepal length in centimeter, sepal width in centimeter, petal length in centimeter, petal width in centimeter, and species. So we are having 6 features. So here we can see that there is a data.shape. There are 150 records inside the whole data set, and there are 6 features. Okay, now by features and its data type, all the 6 features are here, and all their data types according to the values which are present inside the column. The data type are here. There are no any null value present inside the columns. Okay, here we can check statistical analysis. There are how many counts of records, mean value, standard deviation values, minimum values, maximum, and there is a 25 to 75 percentile values. Okay, so now we are going to check visually how data represents inside the data set. So we are using pair plot for the iris data set, and by using color, hue means nothing but color here, spaces are the color. So there are 3 type of actually spaces different type of setosa, Virgica color, like that. So sepal length, sepal width, sepal petal length and petal width. There are four main properties or main four parameters which are actually impact, or it will suggest us which type of species it is. But actually we are using unsupervised machine learning model, so all are nothing but all the features we are using for model fitting. Okay, we can see that iris setosa is easily separable from other two. Iris setosa, iris setosa, iris setosa, iris setosa, easily you can check, it is very separable. And virginica and versicolor are almost, they are nearby to each other, means their properties are almost nearby, as compared to if you are seeing setosa, it is very different from main part, main two, versicolor and virginica. Okay, now here let's look our data through scatter plot, sepal width and sepal length. For sepal length and sepal width, here is the scatter plot, and we are using, to start k means clustering, we have to find optimum k value, means cluster value, and we have to visually plot it. It is our main aim. Okay, let's check. So generally I have instance here, I have making instance of k means by using 5 cluster is by default I am taking as not by default, I am just taking as a 5. Okay, and by using 5 I am predicting fitting and predicting x values. So x is nothing but hold the data set. Okay, hold the data set, and my model is also fitted as well as predicted for all the values. So they are clustered in 0 to 4 by using 5 number of k. So there are 5 groups which are similar. But now you can see that the output of k means clustering model is equal to k is equal to 5, and note that we can find the centers of 5 clusters from the data. So we are used here 5k number of clusters. So by using 5 we have created 5 clusters. Okay, but we don't know how actually how to find or how to choose the k value. Okay, so we are using here the elbow method. Okay, the elbow method. So we elbow method, how to choose k value, where k value here which is get flat from the forward values, so we can choose this value as a k value. So from elbow method we can easily select the k value or number of clusters is equal to 3. There is a flat, there is a no maximum change forward. So before that you can see it is very large change in that, but from here there is a no change. So we can select optimum number of clusters is equal to 3. Okay, by using 3 again we are applying k means clustering model and fitting again and prediction. So there are there are centers which are available here, and we are, by using this we are just visualizing it. So you can easily find out there is a iris setosa color and their centroid, and this is for virginica yellow color, and this is centroid, and for red color is for versicolor, and this is a centroid. So we can clearly see that there is a 3 clusters in the image above, and each cluster represents a different color of centers and also different colors different group of uh, group of groups. Okay. Okay. And yeah, finally we have got the number of clusters and visualization that came in clusters. Okay, thank you for the video. Thank you.